the screen right now is that you are more than welcome to interrupt me if you have any questions throughout the training. And I just want to say, give you some words that there are no stupid questions, just questions that are yet to be asked. So feel free to ask. It will benefit everyone, most of it. Okay. So without, I think, okay, that's it for the ground rules. Before we start, let me give you a little bit introduction about myself. So I go by the name Wanda. You can call me Wanda. I heard something. Can't hear the sound. Can't hear the sound. Okay. Let me switch to another one. I'll just go by this. How about now? Can you hear the sound? Can someone open the mic and let me know?
Yeah, I can hear you now.
All right. So yeah, before everything start, I would like to give a little bit introduction about myself. So I go by the name Wanda, and you can call me Wanda. And okay, I have been making this joke since I think like a long time ago. Up to this point, it's almost like not funny at all. But I'm going to do it anyway. So my name is Wanda, and it's always easier to memorize my name with Wanda Coffee. Tastes just like it was just brewed. Definitely not sponsored. So, oh, I just heard something. Okay, great. So, yeah, enough for the joke. So I'm a fresh graduate of bachelor degree in electrical mechatronic and engineering in UTM. I think just last year only I just graduated. So let me just pull this here. Yeah, so that I can see the chat. All right. So continue. So I was I'm a alumni of Airost UTM Airost team. Back in my day, I was a chief marketing member in the team, and also a developer and all that lah. So and currently I'm working in Vitrox Agritech as a full-time research and development engineer. So before we get into what is roles and all that topics, right? I would like to just to just kick on some of the setup that we should be doing, and I'll explain everything along the way. So I'm pretty sure that we have y'all have read this prerequisites, and I requested y'all to download and install the VMware workstation, and also download the Ubuntu 20.04 long time sustained image files from both of these links. And now we're going to install the Ubuntu. While we're installing, waiting for it to install, I will explain what it roles and all that lah. So let's you can just follow along if you want to. So you can fire up your VMware. Just a disclaimer: VMware is not VMware workstation is not commercially used. It's a software that is non-commercial. So that's why we are not earning any money from y'all. So that yeah, it's free for you to use it personally. But in this way, you can just start by clicking this create new virtual machine over here. And you see something like this pops up, and go to browse and search for the image Ubuntu 20.04 long-term sustained image file that you just downloaded in the prerequisites. Press on it and click open, and click next. Now you can just give a name for your Linux machine. In my case, I'm going to just name it Ubuntu, and my username I'm going to put my name and my password. Cool. Now you can just press next, and you can just give your virtual machine a name so that you can see it's on the list over here. So in my case, I'm going to just, you can name it whatever you want, but I'm going to just name it this way. Just mention it like this. or you can just name it any way that is easier for you to remember. So once you name it, just click next. And for RAWs, I'm going to put maybe a 50 gigs, but depends uh, on your device. You can just put it at least 20 gig, recommended 25. And if you can go more, I'll just you can just go for 50 and more. Depends on you. So once you set the size, you can just click next. Okay. Now for this, you can just customize the hardware. And you're gonna go to this network adapter. Click on bridged, replicate physical network connection state, just for the setup. All right. And for USB controller, you can just switch to USB 3.1. But you can just skip these all this stuff if you haven't reached here yet. Okay. But you can just rewatch the recording as mentioned by I think Xiyuan or Lia Xin. So once done, you can just click on close and click finish. Now it should be taking some time to install or to set up the virtual machine and all that. Okay. Okay, let it boot it up first. I think over here it should take a little bit of a time to boot it up. So let's see how many times would it use. But anyway, once you already set up your virtual machine, I think you can just leave it there first. You should go for this one. It should take some time. So let's continue with the training lah. This is just for the setup. You can just put it in the background and we can just continue. Everyone cool? Cool. All right. Great. So, okay. Next, let's go to the next one. Let me introduce you ROS. ROS, the full name is Robot Operating System. Obviously, that's why you just hear. But what is ROS? Before everything starts, I would like to just clarify something that is very, very important to you guys. Is that ROS is not an operating system. Okay? It is not. It's called robot operating system, but it is not an operating system. Sounds crazy, but whatever. Let's see why. ROS, you can call it, it is a framework and a collections of tools that runs on top of an operating system like Windows or Linux. And the Linux OS that you just used just now is called Ubuntu. It is a variant of Linux. Okay, so ROS, again, ROS is a framework and a collection of tools that runs on top of the operating system. See what I did there on the bottom right corner? Yeah, the penguin is represent Linux and all that. I'm not going to explain about the jokes that I'm hide over there, so it's not going to be funny. Anyway, so you might ask, like, okay, so ROS, it runs on it is a framework and a tools that runs on top of an operating system. So what's the big deal? Now, why do you need to learn ROS? Now, maybe just ask like, okay, what's the big deal about this framework and a bunch of tools that comes with ROS, right? So here's the answer. First of all, I'm pretty sure some of you might know, or probably even know because of the popularity of these companies, which is DF Automation, who is who the co-founder of this of DF Automation is actually one of our supervisor in UTM Airost team, and it is one of the top robotic competition. What was that? I just heard something, but I'm not sure what I just heard, but whatever. Okay. Okay. So for where was I? Okay. Dr. Yong. Dr. Yong is the supervisor of GTM Airost team, and he's the co-founder of DF Automation. And this DF Automation is one of the top robotic company in Malaysia. In Malaysia, our local one, steady. And okay, so you say, okay, DF Automation is local company. How about the rest of the world? You have this ClearPath Robotics. It is used by ClearPath Robotics, and over here you can see that this is the Boston Dynamic Spot robot. ClearPath didn't create this robot, but they are more like creating the ROS package. ROS package, more on that later. Okay, so they write a ROS package that supported the ROS robot, much like the company Fetch Robots from I think it's uh, from somewhere, but okay. So you can see a lot of companies they are using it, including Sony. They want to buy from this ROS also. But what is the common thing that they do to ROS is that they are widely used by them. ROS is used by them and supported by them, by all these robots. And there, of course, there are a lot of other companies that are using ROS also. So if you are here because you're preparing yourself to become, I don't know, a robotic startup in the future, that you want to build a robot, build a robotic company, or if you want to join a robot, if you want to pursue your career in robotics, then this is why you should run ROS. Now, you may ask, when do you use ROS, right? Like you now you know why do you use the ROS, but when do you actually use it? Now, before I just proceed to the to the next content, I would like to sort of ask y'all a little bit, do a little bit of a survey throughout everyone. I wish everyone can just switch on your camera or your mic so that we can talk. Thank you, Suyan, for sending the link to DF Automation. Yeah, awesome. Okay, so a little bit survey to you all. Like, how many of you have experienced in building robots, or do you have frequently built some projects on your own? How many of you? You can just press the raise hand button. Also can lah. Oh, very convenient. Nice. All right. So how many of you have built your own robot before, or interested even not even a robot, but if you have done something with Arduino or Tinsy or any kind of STM32 or any kind of microcontroller that you have been using? Oh, great, great. We have a lot of very active participants. They are in robotics and building this tech stuff. Huh? All right, but it's okay if you never touch anything of those. So I think there are quite a lot of you are quite familiar with Arduino. But how many of you didn't are not very familiar with Arduino? May I know? All right, maybe you are quite new to these microcontroller kind of things, but Arduino is basically, it is a very affordable, popular, and their community is very large, and pretty much it is widely popular amongst the students to develop their own projects, all the way from robotics to IoT and all sorts of stuff. Okay, so you can do a lot of things with Arduino. Okay, now just now I saw some hands. Maybe I can heard from Ricky. Ricky, is Ricky here? Just now I saw her. Or let's see who do we have just now. Okay, just now who was those among those who raise hand because they know Arduino? Can you raise again? Can you raise your hand again? Okay, Harish Shah. Can you open your mic?
Hello.
Hi, Harisha. So I see you are quite familiar with Arduino, and now I have a few questions for you. Okay, let
Okay.
me share the screen again. So you have Arduino, right?
Yes.
Okay, so now in Arduino project, you can you attach an infrared sensor like this to your Arduino?
Yes.
How about ultrasonic sensor?
Also yes.
How about a rotary encoder for robots? For your motor?
Absolutely.
Okay. Now, how about camera?
I don't think so.
How about a lidar sensor that is often used in autonomous driving car?
Uh, I don't think so.
How about a good old Xbox 360 Kinect?
Okay, I think that is definitely not.
Okay, so now you can see that the top three sensors that we have over here, those are very commonly used in the Arduino projects that you can use to build any kind of project, including your robots. So, but how have you ever wondered how do those like companies like DF Automation, ClearPath, Boston Dynamics, how do they build robots that use lidar, that use camera, that use Xbox 360 and all that? Like, how do you integrate this with the microcontroller? So this is when the ROS comes in. Well, to be clear, that those complex sensors are not directly connect to the ROS to the Arduino, but they are connected to some computer like your own laptop right now, or even a single board computer like Raspberry Pi, Jetson Nano, Jetson Savior, and all that things. So you can connect these complex sensors to those devices and communicate with your Arduino through ROS, which will infinitely expand the possibility or the potential of your Arduino projects. So this is when you should be using ROS. Now, we can simplify the whens of using ROS by into three category, not three category, but three parts. First, you can do quick prototyping. With ROS, you can reuse the code from your previous projects, and without, let's say in the future, you are changing from Arduino to STM32 and whatnot, and you don't want to rewrite the code and maybe another microcontroller that only support Python, because I know Arduino is using C++ language, and now you are currently using, I don't know, any kind of a microcontroller that only use Python or something like that to program, and you want to reuse those code, but you don't want to rewrite all the code and all that. So you want to reuse the code from previous project. This is when you should be using ROS. More on that later. How? Okay. And the second thing is you can reuse the code from other developers without breaking your heart, breaking your head. So there are a lot of others developers in ROS because the community is so big. It comes from around the world. So they have developed quite a lot of projects on lidar sensor, on camera, on AI, and all that into their robot. So, but if you want to do quick prototyping, you are not going to spend maybe like 1 year or 3 years just to do the same thing. So you don't need to reinvent the wheel. ROS can help you to do those things quickly. The second thing is you can use complex sensors like I mentioned just now, like the LiDAR sensor that are commonly used in autonomous driving robot, autonomous driving cars, and cameras that are used in Tesla, or maybe even your own webcam also. And as well as the Xbox 360 that you can see from the bottom right. Lah. You can scan 3D in a three-dimensional space and map it out everything for your robot. The third thing is that you are able to control industrial grade actuators like robot arms. So before we proceed to the next few topics, let's have some quick quizzes. Okay, so let's see. Who do we have here? Let's see. Aiman Razin. Aiman Razin.
Yeah, yeah.
Yeah. Okay. So the first question for you: what is ROS?
Robot operating system.
A robot operating system, and what does it do? Why? Like,
It's
what is
like,
it?
an framework that working on running on operating system like Windows and Linux.
Correct. It is a framework and a collection of tools that runs on top of an operating system like Windows and Linux. Perfect. Awesome. Now let's see the next one. Can we have Chong Sin Fat? Chong Sin Fat?
Yes.
Yes. So the second question is for you. Why do we learn ROS?
Mm, to create a robot,
To create a robot and
integrating the something like LiDAR, isn't it?
yep. Actually, it is. Why do you learn ROS? Is because it is widely used and supported by a lot of some of the top robotics company in the world. Now you're preparing for it. It's basically you can ask this question to yourself like, why are you here? So the next question: when do we use ROS? Let's see. If I don't call out, if is there any volunteers that want to answer this question? I see Muhammad Hijami bin Muhammad.
Hi, hello.
Hi. So the third question, when do we use ROS? Can you answer that?
If you want to develop robots, I think.
When can you be more specific?
Uh,
Okay,
sorry.
it's okay. Let's see. Maybe we have someone else to that can try. We have someone type in the chat. I heard something. Eh? Sha. Oh. Oh. When where do I? Okay, Harris. Harris. Yes. Can you help? Can we help? To answer that?
When should we use ROS? Is it?
Yes. When should we use ROS?
I think for complex sensors like LiDAR, camera, and etc. Something like that.
Correct. So to be we can actually divide it into three parts. First of all, we can use it for quick prototyping. This is when we use the ROS. And the second thing that you answered it correctly, which is using some complex sensors on your robot with ROS. And the third thing is to control industry grade in actuators like robot arm to your robot. Okay. Don't worry. Later, I will after the sharing the training, I will just send these uh, slides to you all so that you all can refer it back. Okay. So yeah, I think that's it for this session. So ini macam lah. Okay. So for those who don't know ini macam means in Malay, this is called like this. The definition is like this. So you can see the boy is actually giving you a thumbs up. Okay, before we go into the next session, let's take a break and we'll just go into the next session so that it is more technical and uh, more into the ROS. Okay, let's take a 10 minutes break, shall we? You can go for bio break and all that. Lah. All right. Welcome back. So, okay, since everyone already have their own bio break, so let's continue to the next part of the training. So, now this is the overview of the general idea of ROS. Now, hold on. It may looks a bit complex to you right now. Let me explain one by one for all of these components. All right. So just to make sure that everyone can hear me, right? Just in case I didn't explain again. All right, great. You can see the screen as well, right? Awesome. So okay, okay, now you can, if you look at this the screen, right, you have the ROS master, the node one topic, message, public, subscribe, and all that things. Oh my god, there's a lot of things that to say. But don't worry, let's go through one by one. Okay. So for ROS, it's actually there is a sort of like a mastermind, or we call the big boss of the ROS, we call the ROS master. And what it does is actually to manage the communication between the nodes. What are the nodes then? You may ask. Now, if you look at the if you look at over here, there is a thing called ROS core over here, but later we'll be going through all more details on that. By the way, I think we should go and check out the Ubuntu site, see whether or not we have done finished the what we call the installation. Maybe seems like I have crashed it somehow. It's okay. Let me just switch it on. Switch it back. For you can just go and check your VMware, and you should be installing your stuff right now. Okay, it's okay. Okay, let me just restart it for the Ubuntu. How's your may I ask how's your progress on the installation of the Ubuntu right now? So is some of you still sort of like is still running at the background and all that? Okay, some of you all have already done it, and I think for the next one we should proceed to install ROS on it. Yeah, but let me just boot up my my Ubuntu on my side. So okay, looks like mine is still somehow it is running, but it's okay. I got some backup also. Let me just close this one. Oh, okay, it is doing something, but it's okay. Let me before we proceed to the things. Let me introduce you to a website called ROSWiki. If you don't know how to go to this website, you can just go on Google and search for ROSWiki. And the first link that you see over here is ROSWiki documentation. Just press on it. You should be seeing this page. And this is basically, this ROSWiki page is basically one of the best and the only well-made, well-documented website for everything about ROS, including ROS 1 and ROS 2 and all that. But now, today throughout this training, I'm going to showcase, share about ROS 1 only. For ROS 2, because it is just released back in 2020, the ROS 2 is not very mature yet. So we are going to explore in ROS 1. So if you click on this install over here, just press on it. You should be directed to this page, as you can see. Is everyone seeing the right screen that I'm showing? All right, sure. Okay, so okay, as you can see from here, we have a few version of ROS. Actually, we have more than these, but these are the most recent one. You can see there are ROS melodic and ROS noetic and all that. So basically, what are these? Okay, so for ROS, we just like Ubuntu, we have different version. Like for Ubuntu, we have like Ubuntu 18.04, 20.04, 21.04, and all that kind of thing. But for different version of Ubuntu, there is a different version of ROS for them. So as I mentioned in the prerequisite, I require you all to install Ubuntu 20.04. So the ROS that we are going to use is the ROS Noetic. So you may be wondering, what are these melodic and noetic and all that? So these noetic and melodic, all these kind of things, or we also have got Foxy, Galactic, Kinetic, or even I forgot already, Indigo, maybe. So these names is what we call as distro. Okay, so distro. These are the version name of ROS. So because we are installing, we installed Ubuntu 20.04, so we're going to go ahead and click on ROS Noetic. Right, looks like my Ubuntu is boot up. Let me just key in my password. Cool. And okay, continue to this website. You can just press on Ubuntu. You can see that you have a lot of platform over here that supported ROS. And I would say that the most stable one is usually the Linux lah, which is Ubuntu that you have here. And Debian is for the Raspberry Pi and Justin Nano and all that. And they also have support to Windows, because back in my day, Windows, if you want to run ROS on Windows, it is a bit of a hassle. I've never tried it before because it is very buggy and not worth it. So, but because a lot of I think a lot of people are using Windows nowadays in the world for their computer, so they released the one that supported Windows. So by the way, because we are using Ubuntu 20.04, just click on Ubuntu. Now you should be directed to this page called the installation of ROS Noetic. Now, this page will show step by step, every step that you should be do to install your ROS on your Ubuntu machine. And it also explain every single things. If you want to read through it, you can read through it. But no worry, I will explain to you one by one later. So let's go back to our Ubuntu. You should be seeing this kind of a page. It's a bit buggy, but just skip this one. Next. No, I don't want to send the system info. You can choose to send if you want. And for private service, nope, no thanks. Next, and click done. You should be greeted with this interface. This is the desktop for Ubuntu. And every time I started to install a Ubuntu, I will just go ahead and run a certain command. So you now on your use your mouse, click on this Ubuntu VMware Ubuntu page, desktop. Press Control, Alternate, and the key T for Tiger. And you should be greeted with a terminal. This is what we call as a terminal. Just like the command prompt in Windows, this is the terminal that we use in Linux machine. So the first thing, usually when I start up a Ubuntu or Linux machine, I should start with a few commands that I want to use. But before I go ahead and type it, let me just enlarge the text and all that, maybe. Okay, let me just enlarge it. Custom font, so that you all can see it better. 20 maybe it works for you. Can you guys see my terminal properly, or is it too small and all that? Okay, all good. So the first command that usually I would run is just sudo apt get update. Sudo means super user do. pretty straightforward. It's just a short form of super user do. apt get is sort of like tools for you to download and all that. But apt get update, it is quite self-explanatory lah. For Windows machine, usually you are greeted with a surprise update that when you're restarting or shut down your computer, when you're rushing to somewhere, and just the update just came out of nowhere. But on Ubuntu or Linux, you can control it yourself. You can choose to update anytime you want. But for now, we're going to just go ahead and update it. Type in your password. It should be start running. And the first time that you run the update, it should be either quite some time, takes quite some time, or it should be very fast like this. And the second command that you should do is, okay, here's a shortcut. You can just press the up key on your keyboard and delete the update into upgrade. Everyone follow? And now you should press enter. It should run right away. Here, you will see, it will ask you, do you want to continue? Just press Y, enter. Now, what you just did is basically just run a Ubuntu updates and upgrade lah. Basically, it's the window update, equivalent of window update. So let it run first, and we'll come. Okay, it is quite fast also. Okay, it should take around 2 minutes, I think. So while it is running it, let's wait for it to update for a while lah. Let's go back to the website that we have over here. This is the installation page of ROS Noetic. And you should straight away see these commands over here on these boxes over here. Let me just enlarge a little bit on this page so you can see it better. So over here, you don't need to go crazy. So all you need to do is copy and paste. Okay, on Ubuntu, you can just, on your machine, you can just copy or Control C and go back to your VMware. Let it run first. Okay, this is more than 2 minutes that I expected. But it's okay. We're going to go through, but don't worry, I'm not going to waste all this time just to explain, oh, you should follow me to copy and paste all these commands. But I'm going to explain more on that. Like for the first one, now it is to set up your Ubuntu machine in order to accept the software that is coming from the packages ROS organization. Because if you straight away go and call this download this ROS distro master and all that things without sourcing it, you won't be able to access it because how to say because your Ubuntu computer, your Ubuntu machine won't accept it because you haven't declared it yet. Okay, maybe we can run on the another tab. On the other tab, you can just press on the top left corner lah, over here. Just press on here, and you should to paste it on Windows. I get it. You can just Control V, or you can just use your mouse to paste it. But I'm going to use Control Shift V for van. So no need to type in everything. Just paste it over here and click run. And just key in your password. Okay, so we can just proceed to the next one. This is curl, which is another tool that is quite similar to apt-get. So you can just press it over here, press enter. It should start right away to download these curl tools. Let's see over here, these upgrade tools I haven't done yet. Okay, so it won't run because you just now we are doing some kind of apt upgrade over here. You haven't finished yet, so let it run, finish it. So once it is finished over here, it should be finished over here as well. Anyway, while we're waiting for them to download and upgrade and all that, I think we should proceed to the slides. For this website over here, we'll go through everything later after the upgrades and updates and all that things has been done. Okay, all cool. I just finished saying that. Whatever. Okay, looks like mine is already finished. Okay, let's anyway just once it is done downloading the curl and upgrading all the stuff over here, you can straight away just copy the next command lah over here. Just copy it. Nothing too fancy over here. It basically just grabbing some of the packages and all that. Now, once you paste it, you should say OK over here for the curl. And let's update it first, okay? Because you just inserted a new keys and all that into your Ubuntu. Now you should update it so that it updates the directory and all that. This should take just a while only. And the one that is going to take a lot of times is the next command over here. Now over here you can see that there are several version of ROS that you can install. Not the kind of version of Noetic. They are all ROS Noetic. You can see over here, but it depends on your computer. Like for example, for here because you're using your own laptop, so we're going to use the desktop full version so that it includes all the tools that we mentioned in the first few slides. That we say ROS comes with its own frameworks and tools. And so if we run the if we download or install the full version, desktop version of ROS, then you should getting some 3D, 2D simulator like RVs and maybe even Gazebo, I believe, RQT and all that. I'll explain all that in a moment. Don't worry. So, and if you want to go for a lighter version, let's say you are not running your ROS on your laptop. Let's say you are running your ROS on Raspberry Pi or even Jetson Nano. Those single board computer cannot support too many graphical usage. So usually we'll go for the base version of ROS. Those do not come with a GUI because you don't need to. So we're just going to go ahead and install the full version, copy it, and paste it on your terminal. Press enter. It should run right away, and it should ask you, it should ask you should it proceed? Just press Y and enter, and it should start the installation right away. And this will take some time. Okay, probably even half an hour or 12%, depending on your internet speed. So while waiting those things, let's go ahead and go back to our slides, shall we? Let's see. Okay. Now, while we are installing the ROS in the background, let's talk about ROS again, ROS master. Now, a little bit of recap just now. Is that this is the entire picture of ROS. You can see that this is the general idea lah. You have several nodes, you have publisher and subscriber and all that things. But what are these, right? Now, I'm going to explain one by one first. The first one is ROS master. Just now, as I mentioned just now, it is sort of like the big boss of ROS. It is the one who manages the communication between the nodes. So don't worry about this ROS core over here. I will explain it later when we have some more hands-on. So just now I say manage the communication between nodes. But what are nodes, you may ask? Nodes is what we call as, also known as ROS nodes. It is a single purpose and self-sustaining, or how to say, it should be calling independently executable program. Like for example, you have a Python code that runs on its own. Let's say you have a camera. You have a camera and you are running a Python code that is reading the images from the camera. That's it. That's all he do. That is considered as one node, one ROS node. And you have your Arduino that is running on a C++ code, and it is running by itself. So technically your Arduino is running on one node as a one node. So you can have multiple nodes. You can have more than two nodes. You can have hundreds of nodes and everything. as long as the node must be a independently executable program. Either it is written in Python or C++. And every node, it should be organized inside of a ROS packages, in a ROS package. Just now I did mention about ROS package. So more on that later. What is a package and all that. So, okay. And you can see the code over here. These are ROS run, the package name, the ROS node list, and ROS node. These things I will re-mention again when we have hands-on. So a packages, a ROS package, just a quick one, is basically some, as I mentioned just now, you want to reuse your code or even use the code that is written by another developer. And usually when they publish out their code, they'll put it in a form of ROS package so that it includes all the necessary files that is required for your ROS node. Okay? So let's proceed to the next one. ROS topic. Okay. So ROS topic, what is a ROS topic? Because you want to make sure this the node 1 and node 2 can communicate with each other. But how do they communicate? When one node, let's say node 1 is written in Python, and node 2 is written in C++. In the traditional way, usually we will just try to write in the traditional way when you write and when you build a robot. Okay, so what you do is you will write the entire code into one file, and only one file and one language for that particular robot. On your Arduino robot, you just write in everything in C++, right? So what if you have, let's say, a camera or a packages for the Xbox 360 Kinect or the LiDAR, and the drivers are all that are written in Python, or even you have your AI. Let's say you are running YOLO and all that, and you're writing in Python, and you want those nodes, those Python code to communicate with your Arduino. So you can't just rewrite the code in Python or for Arduino or something like that. It is going to take a lot of time. But because I said ROS is something that connects them together. So this is where how they communicate is through a thing called a topic. Don't worry, it may sound a little bit complex to you, but later I will visualize in a much more simpler way so that you can understand it properly, easier. Okay, so a topic is basically helps the nodes to communicate between each other. So a node can be called as a publisher and the subscriber. The name is quite self-explanatory, but for those who don't know, publisher is basically someone that speaks something, and a subscriber is someone that listens to what the person speaks. And the topic is basically how they get those information. Don't worry, take your time to digest those. Later, I will visualize in a much simpler way. So like you have all these publisher notes and subscriber notes, and you have the topics. And usually, how do they communicate with each other? Because you have all kinds of data. You have string, you have integer, you have float, you have double, and all kinds of things, complex data types. So this is where the ROS message comes in. These nodes, they are all communicate in a form of message. In a form of message. Okay, so this message is basically a sort of things that are that specify what kind of data that should be sending to the topic. Okay, so it basically it mentions all whether this data is integer, a float, a boolean, a string, or any even an array or something like that. So okay, now you have all the pictures of ROS already. Now let's get back to the overall kind of a overview of a ROS system. Now, I'm pretty sure that some of you maybe already understand what is going on over here, but some of you might not be able to master or understand what is going on over here. So let me visualize it this way. Okay? Now, do anyone doesn't know YouTube? Is there anyone doesn't know YouTube? Maybe you can raise up your hand. No? Okay. How about anyone who know what YouTube is? Maybe you can raise your hand if you know what is YouTube. Maybe I just show YouTube just now. Just play song on YouTube. All right, great. I'm pretty sure that most of you all know knows what is YouTube, and apparently nobody knows what is YouTube, because just in case, man, I'm 24 and I need to make sure that I'm well communicated with the younger generation. Just in case, because I just really just met some young kids in a robotic competition as a mentor, and apparently they are not using Facebook or Instagram anymore. So I feel a bit disconnected from the younger generation. So just want to make sure that everyone know YouTube. Okay. Anyway, let's come back to here. So how do we? Why do I visualize ROS Master as the YouTube? Now, how many of you know the YouTuber PewDiePie? Felix Schaubert? Who doesn't know PewDiePie? Who doesn't know the YouTuber PewDiePie? Or you can just call it a YouTuber if you don't know him. And here we are. We have us, the viewers. Okay, I don't have a proper. No, I don't have an image that shows us because there are a lot of us. So I just put a cat lah. So we are the viewers. And usually, how do we communicate? How do we, as a viewers, how do we watch the YouTube, the videos from the YouTuber? You also often heard them say that, hey, subscribe to my channel. Please subscribe to my channel to watch more of my video. This is what they say. This is what they usually end their video and all that. So you can see the ROS topic as a form of YouTube channel. The YouTube channel, the PewDiePie YouTube channel, and the PewDiePie himself is the YouTuber, and we are the viewers. And the messages you can visualize it as the video. So if I visualize it this way, would it be easier for you to sort of understand what is going on over here? Or do you still have any difficulties to understand? All right, let me just explain a little bit more. The YouTube platform is basically a website, right? It's a website that contains full all of those YouTube videos that you can watch, and it is the one that manages whether the viewers should be watching which YouTuber and which YouTuber's videos should be publishing to which viewers, right? So, and the YouTuber, they will upload their video onto their YouTube channel. And we, as the viewers, we will get the videos from the channel because we have subscribed to their YouTube channel. So you can see that we, as the viewer, are the subscriber, and the PewDiePie himself is the publisher. So let's go back and look at the original diagram. You can see that the ROS master is the one that makes sure that not that the publisher node is sending his message to the subscriber node through a things called topic, which is the YouTube channel, in form of what? In form of videos, in form of messages, ROS message. So yeah, this is the another way of describing what is a ROS. Okay, I hope this will help you to sort of understand more onto the general idea of ROS. So this went a bit too fast, faster than I thought actually. So let's go back and see how's the progress of our installation for ROS. By the way, is there any question from the participants? Because if you have any question, please ask me the questions. please interrupt me, open your mic or type in the chat as well. Just ask me any question that you need more explanation on that topic. I guess there's no questions. If no question, you can please. Yeah, okay.
Yeah, I have a question.
Yeah.
Okay, so this Linux is operate in virtual machine, right?
Yes, yes.
So let's say if I own a laptop that use Linux as its operating system, can I use it for ROS as well?
Definitely, definitely. The reason why we are using a virtual machine is because back in the day we used to dual boot our computer. So what is happening with dual boot is that we have Windows running on our laptop, right? And we can't have we actually can have two operating systems running on our laptop. So what we do is we dual boot our laptop. But in this way, there is a problem because some of the laptop or some of the manufacturer of the laptop somehow they are they when you install Ubuntu on your laptop, there are a lot of bugs that you need to fix. So that is why in this training we'll be using the virtual machine. But if you have a laptop that is or any device that is already running mainly on Linux, yes, definitely you can run ROS on it. You can just run it, no problem, no problem. 18.04, if you say that, oh, now we are using 20.04, so that's why we are using ROS Noetic. But if your Linux machine was running 18.04, you should go for Melodic. But the procedure is almost the same. They are almost the same. The differences between Melodic and Noetic, yeah, okay. This is where the differences come in between both of these versions. Because ROS, they used to run only on Python 2.7. Okay, Python 2. Now, if you have done any projects that is related to AI like TensorFlow or PyTorch and all that, you will notice that you have been using Python 3 most of the time. Python 3. But if the ROS Melodic, they are all using Python 2, then how will you uh how sort of like communicate if the ROS is running in Python 2, but your AI project is running on Python 3. So like how do they communicate and how do they run with each other because you have multiple version of Python. There is a way for ROS Melodic. But however, I'm not going to cover those in this training lah. If you want to know about how to run Python 3 on your ROS Melodic, yeah, feel free to ask in the future. Just chat with me, just or just contact me through WhatsApp and all that, or emails as well. But in this training, we're going to focus on ROS Noetic, which is running on Python 3. Okay. Well, what was the question? How did I went this far?
Yeah, kind of detailed, but I get what you're trying to say. Thank you.
Yeah. Yeah. All right. Sure. Is there any other question from the floor? Just ask any questions if you have. I will just count for 5, 4, or you can just write in the chat. Let me check. I think I didn't check. Is this meeting real? Yeah. Is it recorded? And okay. Okay. Cool. Sudo sounds like a Japanese word. Yeah. My first impression as well. Thank you, Zihao. And okay, so looks like my ROS is already done, finished installing. Let us continue to the next one. Let's see. So now at this point, you basically you have already finished installing the ROS Noetic on your robot on your machine. So let's go back to the slide a little bit. As you can see, just now I did mention you have this ROS core over here. This is the command for you to run or to to start your own ROS master. You need to wake him up. Okay, This boss, you won't run it by its own. You need to wake him out first before you can do anything on ROS. So now let's go ahead and type it and see what happened. When I press enter, nothing happened. Right? Oh, what is going on? Because okay, obviously you haven't finished the installation. You just install. Yes, the ROS is already inside your computer, but you haven't tell your Ubuntu machine to know what the hell is this command. It doesn't know. It doesn't know what is ROS called because yeah, you install it, but it doesn't know. It doesn't know that what the hell is ROS call command. So the next part is to source your ROS root file. So before I go into that, you can just okay, never mind. I'll show it later. Let's go back. Let's go back to the website, and you can go ahead and go to this environment setup 1.5 and copy this source opt ROS noetic setup.bash. Copy it and paste it on your terminal and press enter. Nothing comes out. But what is actually happening over here? What is actually happening here? If you type ROS call, now your Ubuntu machine should know what the hell is going on and what the hell is ROS call. It knows already. But how? What does this do actually? This source, opt ROS noetic setup bash and all that. Okay, let's take a minute and open up a new tab. Now over here, this new tab, I didn't source anything. Now let's try on ROS call again. Again, you go back to the same problem again. Then you may ask, do I need to source every single time when I run when I open a new tab? Because in the future, your robot is going to look like almost something like this. You can imagine there are a lot of things that is going on behind the screen. So like, are you going to run like, if you have like 100 nodes, are you going to just execute the source every single time that you open up the new tab? Hell no. So what is happening here? What you just did on source of this opt ROS noetic setup.bash is basically let your terminal know the command ROS call. But let's do something so that in the future you won't have to write it on your own. You won't have to sort it every single time you open up a new tab. So this is where the next things comes in. Echo the same thing. Okay? Just copy this command and paste it here. Okay. Nothing happened. But you see that. Let me show you what is happening on this code first. Okay. Let's run the next one. Okay. Let's pay. Before we do that, let's look at something. We call ROS $ ROS package path. Nothing comes up, right? You see, echo ROS package path. There's no package path, such thing as ROS package path. But see what happens if you run source again. This curly sign /.bashrc. Let's press enter and let's see. Go back to the previous command. Or just a recap. If you want to go back to the old command that you just typed, just press the key, the up key on your keyboard. The up key on the keyboard. So okay, now let's press enter. Something's happening, right? It shows up. Just now it didn't show anything, but now it shows that, oh, this is where our ROS packages is placed on this machine. Now let's this is all command on the terminal and all that. A lot of you are not very familiar with this. Now let's go ahead and do something a little bit closer to the GUI. Now you can open up your file, your file system, and over here you can see that you have the very common files like desktop, document, download music, and all that, just like in your Windows machine, right? So go ahead and press on other location on the bottom left corner of this, over here. Press on it, you should see computer. Just go into it, and you should see that, oh, this is something different. This directory is what we call as the root directory. Okay, as the root directory. And if you go to home, your username, you go back to home. Okay, so now let's go back to the root directory. And let's take a look at this OPT ROS noetic share. So this is what we call as a directory for those who don't know. Okay, just double click on OPT. Go ahead and go into ROS noetic, and you should see a lot of files over here. Okay, then this folder share over here is basically where all the default ROS packages that comes with the ROS installation. So you can see there are a lot of very basic packages. Like for example, you have all kinds of messages and all kinds of let's see, you have the ROS C++, you have the ROS Python. Those things I'll go into details later. Now you can see all these are in your package, but actually what was actually happening in when you run the command source opt ROS noetic setup.bash. So you can see inside your opt ROS noetic directory, you can see there are a lot of setup over here. So you have this setup.bash, right? So when we run, okay, so when we run the source opt ROS noetic setup.bash, it's basically executing this bash setup.bash. It's basically just sourcing it to your terminal so that it knows that it should look for the ROS packages from here, from this folder over here. And so you may ask, like, okay, I get the source and all this kind of this command over here, but what is this echo and bash rc? So bash rc is basically hidden over here. Okay, you can go back to your home directory, press on home, and okay, just for your information, the curly symbol over here represent the directory of home, which is here. Okay, this is home, and the curly basically just means like that lah. Okay, so you cannot see there is a bash rc anything that exists in this folder. That is because it is a hidden file. So you can just press on here, go to show hidden files. Now you should see more files over here. And now you can just click on the .bash rc. Okay, you should see a text files over here. Okay, a text file over here. It should pop out right here. And a lot of things, these things, maybe you don't know. So do I. A lot of things, I'm not quite sure what is happening over here. But I know that this bash rc basically it runs every time you open up a new tab or a new terminal. Okay, you open up a new terminal, it should run the bash rc. Okay, so let's go back to the bash rc and you scroll all the way down. You see at the very bottom line, you should see the things that you just written over here. Let me put side by side. To the command. See that echo source opt ROS noetic setup.bash inside the bash rc folder. So you see that this should be typed in here. Okay, so this is when you do something like echo and all that. Oh, maybe you have like you may be thinking that, oh my god, there are a lot of commands that you need to memorize. No worry, no worry. Let's sort of like delete this, okay, and make it didn't happen. Okay, make it didn't happen. So now if you open up a new tab, type rosco, it should doesn't recognize what is going on. And what this thing does is basically just open up your home, double click on your bash rc, scroll all the way down, and manually type in source /opt/ROS/noetic slash come on slash setup /setup.bash. So this is what is happening over here, over there. It's the same thing. Okay. Let me show it properly. So basically what this command does is basically something over here. It's the same thing. Just click on save. It should be good to go. Now that you have already included this source opt ROS noetic serial bash inside your bash RC, now let's take a look when you open up a new terminal. Now I didn't source anything. I just straight away just go ahead and type ROS call, and it should recognize the ROS. Oh, because I already run it over here. Let's cancel it over here. And if you run ROS call over here, it should recognize it straight away. Without even you go and manually source again and everything like that. So yeah, now you should when you look at all these, if you manage to run the ROS call properly, you should congratulate yourself because what you just did is just wake up the ROS master. The ROS master is wake up, it's good to go. Okay. Okay, good. So far, can everyone follow? Or is there any questions that you want to ask? If no, you can type in the chat so that you have no answer. You have no questions. No, Myro is still installing. It's okay. It's okay. Take your time. Take your time. You can rewatch the recording, and follow along. Don't worry. If you, as I said, the ROS Wiki website is the best website that you can find, and the best website for you to find anything that is related to ROS. So you can always go back to this website and follow along step by step. And if you want to go ahead and read through everything, go ahead. It is highly recommended if you really want to understand everything properly by yourself. So yeah. All right. So no problem, no problem. All good. Great. Now you have managed to run a ROS core, and as I said, you already now your ROS is up and running, is ready to go. And let's go ahead and finish up the installation for the dependencies and all that. This is, as I said just now, sudo apt is basically a tools for you to install something, just like the pip, the curl, the apt that usually you use in your projects and all that. So let's copy up all this stuff, and because it is ROS noetic, you can see you are using the Python 3 ROS tab. So that is something to look into. Let's paste it over here and press on enter. Key in the password, it should be running. Yes, I would like to continue. And once it is done running this installation of this Python 3 ROS tab and all that, this dependency, you can finish up your installation with the following commands lah, because it basically just install all the dependencies for Python 3 or to run ROS and all that lah. Okay. So while waiting for them, maybe we can go a little further to the slides, maybe. Blah, blah, blah. The YouTube thing going on. Okay. Okay. Now we have really these things. I guess we should just straight away just finish up the installation for the ROS, and we do some hands-on, and then we will have a small quiz later on before we end the training for today's session lah, huh? Okay, so while waiting it, maybe we can have a 10-minute breaks. While the others, if you are already finished installing everything, you can go ahead and finish up all these commands one by one into your terminal. And maybe we can have a 10-minute breaks while we are all doing this. While we're having a break, maybe if anyone have any questions, you can just leave the question on the message on the chat, and even open your mic if you want to ask any questions. I'm always here to ready to answer your questions so that I can further explain more for you. All right. I think that was around 8 minutes or so. But is there any question from the floor before we head into the next part of the session of the training? And we're going to have some hands-on and more explanation as well as quizzes. So, is there if there's any question, you feel free to open up your mic and or even write on the chat if you have any questions that requires more explanations. And yeah, if no, please write also write on the chat if you don't have any questions, and we shall proceed to the next one.
Yes, I have a question here.
Yes,
Just maybe
yep.
I overlooked something just now. I want to ask that for the when setting up for the sources list in the terminal, when I paste the sudo sh equal that blah 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 something in my terminal, it says that for the command is not found. So I wanted that for you scroll down for the 1.2 1.2.
1.2 1.2. Okay, this one.
So I just pasted it in my terminal and but it said the command is not found. So for
Which
the
command?
configuring Ubuntu repos for this one, is it mandatory? Just now maybe I overlooked, so I think I missed this step.
I see. Yeah, if you want to do that, actually, for in some cases, you can just overlook that, but it's not very compulsory. But if you have been problem in the 1.2, please, you can just go ahead and open up the Ubuntu software. If you open up from here, the bottom left corner, can open up the software updates, and it should pop out. This could take some time actually, but it's basically just some setup stuff lah. Okay, here we go. It goes with the updates.
But just now I think I did the update already.
No,
It
no,
just pop up. Just pop up.
Yep. I understand, but that things maybe that kind of issue you can just solve it from after this update maybe. When it should be done by now. Okay, that's why okay, so you can go into the settings over here. Once you have it, press on the setting. It should take some time. And over here, you can go ahead and search for Ubuntu software over here. And you
Okay.
can make sure all these are checked lah. Do you have any anything settings that is different from mine?
Maybe later I'll check.
Yeah. So that problem you can just solve it from here by make sure that your main universe, restricted, and multiverse are all clicked, are all checked, and you should be good to go for that one. If you still
Okay.
have any problem, please feel free to chat me in so that I can troubleshoot for you lah. Okay.
Okay.
Sure. All right. Great. Great questions. Is there any other question from y'all? No problem. No questions. All right. All right. So I think we shall proceed. Surprise! You just have my interface just changed because I did something lah. This is also a terminal, but it is called a terminator. It is optional, but it's also always better for you to visualize everything using terminator. So yeah, not compulsory, but if you want to know on how to install it, you can open up your old terminal and write sudo apt install. Oh, wait. Let me just enlarge everything. So yeah, see, much easier. So you can just sudo apt install terminator. This is completely optional. If you want, you can just do it. If you don't want, you can just skip it. Okay. So anyway, because I already done it, so I'm not going to do it. It's going to take around like a few seconds, depending on your network speed. Anyway, so as you can see over here, I have my ROS core running on this tab over here. So I'm going to just keep it up there so that I can see it is running. So before we proceed to the next part, let's go ahead and go back to the slide first. And yeah, as we can see that just now you have already wake up your ROS master using the command ROS call. So in order to check what the hell is going on, or just now I say the ROS master is already wake up, and what's up with the ROS node, right? So you can see that there is 3 commands over here. ROS run is usually the command that we usually run a ROS node. A ROS node, an executable Python file or Python executable C++ code program. Usually, if it is running on ROS, then you need to use the command ROS run to run the code. And as I mentioned just now, every node are organized inside of a ROS package. So, and I also shown that the packages that you just that you have by default are in the OPT, ROS, Noetic, and share. Yeah, that is your ROS package directory. But in the future, we're going to create our own workspace later. More on that later. Okay. So if you go ahead and check your ROS package path, make sure that it is already inside your directory, this OPT ROS Noetic share. So, okay. Now, if you wonder how many nodes are there that is running right now behind everything, you have the ROS master running and you haven't have any nodes running. But if you go ahead and write ROS node list, it should have a thing called ROS out. This is by default. If you write this, every time after you have activated your ROS master. Okay, so if you Control C is basically interrupt. So you can press on your ROS master tab and Control C to interrupt, just to close it out. And now you go back to the ROS node list, and you can see nothing, because obviously your master is not on, because so that it cannot communicate with the master. So let's run again our ROS core. Wake it up first, and let's go ahead and ROS node list. This is where we check what are the ROS nodes that are running right now at this moment. As you can see, we have the ROS out. And let's go ahead and see what's the next one. You have the ROS node info. So like if you go ahead and type ROS node, this is a command. And if you want to know, because you can't just memorize everything, ROS node list, ROS topic list, ROS echo, ROS info, and all that. You don't want to memorize it, you can go ahead and double tap your tab key, your tab key. Okay, on your keyboard, your tab key, just double tap on it. It should list out everything that you can do with this command. As you can see, you have ROS node cleanup, ROS node info, ROS node kill, list, machine ping, all kinds of a function that you can do. But now we're going to go ahead and type ROS node info. Now, what's next, right? What's next? You can, if you don't know, you can just go ahead and double tap again. You can see, because you have only one node that is running. So if you double tap it, it will straight away fill it out for you. You don't need to retype it for your, manually yourself. So go ahead and press enter. You see that this is the this is the information about all the information all about this particular node. You can see that it is the publisher of this node is called the ROS out AGG, using a ROS graph message to log everything. And who is subscribing to it is ROS out. And and what kind of services will explain it when in the future if we have ROS intermediate and all that. Because I don't want to go into ROS service yet, because it will be quite confusing for beginners. So for this training, we're going to stick with publisher and subscriber. For services, we'll go into it if you have gone through the intermediate training for ROS. So anyway, from here, you have all the info about this particular node using ROS node info. And as if you notice, the first one when we write ROS node list is also one of the function of ROS node. And you can explore yourself if you want to know more what is maybe ping, maybe you just tap, double tap, and press enter. You can see that it is the speed of communicating with this node is around how long does it communicating and all that things. You can explore yourself. I'll leave it to you to do those tasks. Okay, that is all about ROS node. Okay, so far, is there any question beside this? No? 5, 4, 3, 2, 1. Okay, so let's go ahead to the next one, which is the ROS topic. Same thing. You can sort of see the pattern, right? You can see that if it is something related to the node, you can just ROS node. If it is something related to the topic, just type ROS topic. Very simple, very straightforward. And the same practice, if you don't know what kind of a function does this command have, you can just straight away and double tap your tab key and see what kind of things that you can do with it with this command. So over here we have echo, info, pub, and all that, and list and all that lah. And now let's go ahead and just type in ROS topic list so that we can know what are the topics that we have running right now. So, okay, you should have a ROS out topic as well as a ROS out AGG topic. So now let's, can anyone tell me, how do I know the more about these topics? Can anyone just type in the chat or maybe open your mic if you know, if you have any idea on how to do it? Anyone want to volunteer? If you don't, I can just choose anyone, call you out. So, all right, seems that there's no one, so I'm going to call someone. Maybe we can go for Hachana Arulapan. Am I pronouncing the name correctly? Hachana. Harchana, are you there? Chana? Okay, he's not there. It's okay. Now let's proceed to the next person. Maybe we can go with Isaac Ng. Maybe Isaac Ng. Or anyone wants to volunteer to answer how do we know more about these particular topics, like for example ROS out or ROS out AGG. What kind of command should we go for? Someone can volunteer maybe. We have some answer from the chat. Sudo apt update ROS topic info ROS topic. Okay, so Muhammad, nice try. But actually, sudo apt update is basically for you to, just a recap, is to allows you to update. It's sort of like a Windows update. That command is for the updating tasks. So it has nothing to do with the ROS node. But nice try, very good. And for Andrew, he says ROS topic info, the topic name. And Muhammad also reply ROS node info. Okay. For Muhammad, there is also a nice try. ROS node info is for you to know more info about a node, a ROS node, instead of a ROS topic. So if you want to know more about ROS topic, you can just go ahead and type ROS topic. Same thing, info. You are correct, half of it, but just in this case, instead of ROS node, it is ROS topic. So yes, correct. What Andrew has answered just now is ROS topic info and double tap your whatever name that you want to know. Let's say I want to know more about ROS out. So you can just type it out and press enter. You should be able to see the info about this particular topic. So you can see that the message types is ROS graph message, and there's no publisher to this particular ROS topic, but there is a subscriber, which is ROS out. This ROS out is not lah. Okay, this is actually kind of not a very good example. I think we can do maybe some hands-ons on some proper publisher and subscriber. But now I'm not going to go ahead and explain the publisher and subscriber yet. We'll keep that for tomorrow. But you can go ahead and follow me along lah. Okay. So what I'm going to do is, as I said just now, if you want to run a node, you can just ROS run. You can follow along lah if you want. ROS cpp tap tutorial tap and say Docker. ROS run ROS cpp tutorial Docker. Okay, if anyone is following, you can start straight away and type this out and press enter. I will explain everything later. And on the other side, on the another tab, you can go ahead and do the same thing. But in this case, I'm going to ROS run. Maybe I'll go for ROS Pi tutorial, tap. I can go ahead and press listener. I'll explain everything later, but now this is just a demo and to understand what the hell is going on. So, okay, now if I press enter, you can see that both of them have some outputs constantly. And if you notice, the number of hello world, the hello world followed by an integer at the behind, they are all synchronized from both talker and a listener. Talker and a listener. So let's see what happens over here. Now let's go ahead and check again ROS topic list. Now we can see that hey, there's another things coming out all of a sudden. It's called the chatter. So now let's get to know about this fella. Okay, ROS topic info, the chatter. Okay. Now you can see that in this topic, ROS topic of this called the chatter topic, you have the type called standard message string. Okay, the data type is string. And there's a publisher called talker and a subscriber called listener. So what is happening here? Can anyone tell me? You can open up your mic so that it's easier for you to talk. Anyone? Maybe we can call Ricky. Ricky?
Yes.
Yes. Yeah. So from this ROS topic info chatter, what can you tell a story from this info?
Like where is the like it shows the where is the publisher and then where is the subscriber?
In this case, who is the publisher? Who is the subscriber?
Talker is the publisher.
Okay.
And yeah, and the subscriber is the listener.
All right. Great. Awesome. Correct answer. This is the correct answer. This is where you know what is going on behind the ROS. And if we go ahead, by the way, thank you, Ricky. And if you go ahead and ROS not list, you can see that you have more than ROS out. Just now we only have ROS out, right? But now we have a listener and a talker node. So let's go ahead and see what ROS node can do. So okay, you have queue and all that. Okay, now let's go ahead and ROS topic echo. Let's echo the chatter. For your information, echo is sort of like displaying what is inside the topic right now. So if you press enter on ROS topic echo chatter, you can see that it says the data is called hello world followed by a number. So what is happening here? Now let's go back to the diagram that we shown just now. You have a ROS master running at the background, and you have a publisher, which is talker in this case, and you also have a subscriber, which is in this case is the listener. And you have the topic called the chatter, and they are communicating with each other. What is happening here is this this talker over here on this page over here, it is sending out the string of hello world followed by a number, and it is sending out to the topic. And now the listener is subscribed to this topic, and so that he can display it out what he heard. See, I heard hello world followed by a number, and they are synchronized. Okay, just as what Reiki mentioned just now in the ROS topic and info, you can see these are the connection between all of these nodes. Okay, can follow? All right. Now, if you look at over here, you have all these lots of terminals. Sometimes it is very terrifying for some people, for beginners as well. So now let's go ahead and do a little bit of a visualization using GUI, graphical user interface. We have a tools, as I said, ROS comes with a lot of tools by itself. So we have a tool called RQT. Okay, you can go ahead and open up a new tab and type RQT in it and press enter. It should run. It should open up a Windows like so. All right. See, it is blank for now, but it is a user interface. So let's set up something over here, shall we? Okay, we have this topic. Nope, I'm not going to do that. I'm going to just configuration intro. Okay, node graph or package graph. Node graph. I'll just use this one. Okay, node graph. Let's see. So tiny. Hiya. No. Let's go ahead and go for a package graph maybe. Oh, it's the same thing. Okay, whatever. Okay, so from here, you can see this is a graphical interface that shows what the hell is going on. Just as in the what we call this the diagram. So RQT is actually a tools that help you to visualize what is the connection between those nodes. Okay, so you have the talker nodes, and they are publishing to a topic called the chatter, and who is listening to this chatter is the listener, right? So you can just maybe visualize it this way. Yeah, this is much better. So yeah, you can see that if I were to just close this one, ROS topic echo, and sort of go back to my RQT and I refresh, this will be much easier to visualize. Oh my God. Okay, so this won't be too confusing. So basically, talker is the one that is talking, and the chatter is the one that allows them to chat with each other, just like WhatsApp, right? You have WhatsApp as the chatter, and someone is talking to you, and you are listening to them, just like this. Okay, the relationship between them is like this, just like this. Okay. All right, that's good. That's good. Okay, so that is about the ROS publisher and the subscriber. Can't believe I just covered that tonight. Anyway, let's see. Go for the very last activity that we have today. I'm not going to go very detailed on the publisher and subscriber tonight, on how to write publisher or how to write a subscriber. However, since I've already explained the relationship between a subscriber and a talker and a publisher, let's do a little bit of a quiz over here. As you can see over here, we have a robot over here. Let's assume that it is running a ROS robot. It is a ROS robot. Let's say it is a ROS robot that is running on a Raspberry Pi, which is a single board computer, if you wonder. And we have an Arduino that is communicating with the Raspberry Pi. So over here, can anyone tell me what is the role of a camera and an Arduino? In this case, can someone, maybe I can, yeah, I don't think someone will volunteer, but I'm going to call out maybe some random person. Maybe we can go ahead and ask Liesin, our host for today. Liesin, are you there? Yeah. Okay, so on this diagram, can you tell me what is the role of the camera in terms of ROS? In terms of ROS. Oh, we have some answer from Isaac as well, but but it's okay to go ahead. Let's see if you have. Yeah. Okay. The question is, what is the role of the camera in this diagram in terms of ROS? Okay. So the camera, is it a publisher? Is it a subscriber? Is it what is it? What is it? Can you give some answer? Don't worry, there's no wrong answer or not. I mean, technically there is a wrong answer, but it's okay to try. Okay. But we have already have answer from Isaac, but you can try. You can try it, listen. Okay, it's the publisher. Is there any other question from the floor? Maybe someone have the same answer or a different answer from Liesin. Now let's take a look at Isaac's answer. Isaac says, camera is the sensor controlled by Raspberry Pi, and the motor is the actuator controlled by the Arduino. That's great. That is actually the very well explained on this diagram that we have over here. And I think from here, you can see that the camera, yes, it is indeed a sensor. And what Lie Xing mentioned just now, answered just now, is correct. A camera is the publisher right now. Let's say the code on the Raspberry Pi is running, let's say, a Python code that is to read the camera image to do something. So the camera itself right now is acting as the publisher of the ROS system. Okay, so it is the publisher. Now, can someone answer me? What is the role of the Arduino then? What does it sort of like do over here? Can someone type in the chat, or maybe if you want to open up the mic and answer it? Oh, I can call someone. Okay, we have Muhammad. Answer it. Arduino is the listener. Is there any other question? Any other answer yet? That is different from or similar to Muhammad. Arduino control speed of motor. Okay. Any other answer? 5, 4, 3, 2, 1. All right, great. Kai Jin Wang say topic. Kevin Chin say ROS master. Okay, nice try. Very nice try, Kai Jin and Kevin. But for now, actually, okay, now let's take a look at the answer of Kai Jin and Kevin lah. For Kai Jin, the topic, as I mentioned just now, this the topic is actually it's sort of like a YouTube channel for the for the YouTuber to communicate with the viewers. So in this case, the Arduino, you cannot call it a topic because an Arduino, it has its own independently executable program. So and in this case, Arduino is considered as a node. So, and for Kevin Chin, you say ROS master. Okay, for ROS master, it's actually it's not the correct answer. However, it is running. We are running ROS master inside the Raspberry Pi, where the Raspberry Pi is operating under Ubuntu lah. So you have the ROS master on the Raspberry Pi so that they can communicate with each other. It is managing all the communication, and we can see that Muhammad actually answer it. Arduino is the listener. In this case, yes, it is correct, but half of it. As I said, as I mentioned just now, a node can act as both publisher and a subscriber? This is a tricky question, but nice try, very nice try. I'm glad that we have a lot of answer over here. Like Isaac is saying, Arduino controls speed of motors. Yes, it is processing all the PWM and to send sensors to the motor driver so that the motor can vary the speed and all that. Yes, the role of Arduino is correct, but in ROS term, just like Mohammed said, the Arduino is now actually a ROS node that acting as the listener. That is partially correct, but as we can see over here, in some cases, the Arduino itself can be a publisher as well, because you have motors and I think it's on my side wrong. It's not Muhammad wrong. Muhammad is completely correct. But if I were to add an encoder to the motor, in this case, the Arduino can also become a publisher, because it is publishing the it could be publishing the data from the encoder to the Raspberry Pi to do something else. I don't know. Okay, so let's see if we have any other question answer. Raspberry Pi will be the topic. I would say that Raspberry Pi is sort of like the computer. Like now you have your laptop is equivalent to your laptop right now. So Raspberry Pi is a single board computer. It is running the ROS system. It is hosting the ROS master, and it is hosting the ROS topic. Yeah, you can sort of saying it is topic, but not directly is a topic, but it is hosting or running the topic. It is running the ROS master, and it is asking the ROS master to direct those nodes so that they know which topic should they subscribe to or should they publish to, in order to complete the communication. Mama also added it will be publisher for driver. Yes, correct, absolutely correct. This is 100 mark power, Muhammad. Yes, it is the publisher of the for the encoder, to be correct, to be exact. The encoder of the motor, you record it on Arduino, and Arduino will just publish it to the Raspberry Pi. Maybe you are doing an autonomous driving when you press on the screen or something like that. If you have any special software running on your laptop, and you just click on there, and maybe the robot will just go to that particular place on its own by reading from the encoder. Correct, 100%. Yeah, so I think so far the ones who answer the questions, I'm pretty sure you guys have sort of mastered the relationship between the publisher and the subscriber. So far, is there any added questions that you might not clear about it? Maybe you can lie on it. You can open up your mic and ask the questions so that everyone can know. Maybe some questions, maybe you are not very clear with that, but and you are not the only one who doesn't know one or doesn't clear about that. So if you ask the questions, everyone will say, "I'll start to notice. This question I didn't ask. I didn't know. Maybe this question it would be helpful." So that's why I very encourage y'all to sort of ask any question that you want. You can just leave in the chat if you are shy. Which component is the subscriber? Okay, the subscriber. Okay, in this case, you can see that for camera, since just now it say it is the publisher, right? So this camera, maybe it is publishing something, the camera image, and you are doing some AI on Raspberry Pi and all that, and using the images that is coming from the camera. So after it processed using the AI, it published out the data and to the Arduino to do something. Let's say on the screen, I have a camera on me, and I have this mouse with me, and the AI, what it does is to detect the mouse, where the location of the mouse in the frame. Let's say it is on the left side of the frame or the right side of the frame. So if let's say I say if the mouse is on the right side of the frame, then do I mean, the Arduino should ask the motor to turn left or right. If my mouse is on the left, then it should ask the robot to turn left or right. Something that depends on you. Okay, so it can do something. So in this case, the camera is the what is happening in the Raspberry Pi for the camera side is the publisher. It's publishing to a topic, whatever topic you want to name it. And in this case, the Arduino is the subscriber for those information. And it is once it is subscribed to those information, it can do all the output or the action that you have programmed the Arduino to do. Don't worry, I will try to sort of create or write create this kind of projects so that you all can sort of see the demo. Maybe tomorrow in tomorrow's session, maybe we can showcase a little bit before we start everything. Does that clear up your questions, Liang Ming? Great. Okay, so how about the others? Do you have any question for me? Any other questions? If you don't, then I think we can end this session for today, and we shall.
Excuse me?
Oh yeah, Ahmed. Yeah.
Yes. Is there any other labs or something where we could get more experience in this field?
Lab. I'm sorry. What do you mean by any other lab? Mean tutorial?
I mean like a place where we could gather to get more experience if you have questions or something that we have problems that we faced during trying to make any problems or any questions that we might have.
Yeah, I believe we have a WhatsApp group. So if you have any added questions, if you are didn't manage to follow along the hands-on that we have right now, and if you are doing it after this session, you can feel free to put in any questions inside the WhatsApp group. So I will look at it and will answer it either inside the WhatsApp group or during the next session.
That sounds good. Thank you.
Yeah, sure, of course. Mohammed ask, can advise us with some series to know more about ROS, of course. Of course. Yeah. Some series to know more about ROS. Yeah, I mean this one you can discuss with the organizer lah. If we were to go into intermediate, or even we can have a workshop fully in hands-on, so that we can build something out of ROS. But all depends on the organizer also lah. I'm working full time with Ross as well. If you wonder, yeah. So sounds interesting. Okay, great. That would be great. Okay, nice. Okay. Any other question from the floor? Five, 4, 3. Hey, hi, is there a YouTube channel for newbie? The YouTube channel for Ross. I would say if you were to look for any YouTube channel, you can let me see. I remember there are a few. There are a couple of them actually. If you go for YouTube, maybe you can look for the construct. The construct, maybe. Yeah, the construct is actually a very professional YouTube channel. Okay, the construct is actually under it has a sort of like a what we call the collaboration between another robotic company that is running on ROS, which is Robotnik. So they have a lot of video specifically on ROS, but their videos are usually 1 hour and stuff like that. So if you have time to go through everything, yeah, feel free to go here. But I would say if you were to really want to understand or learn about ROS, ROS Wiki, as I said, is the best. It's the best website that you can find for everything that is related to ROS. Everything, almost. Okay, so yeah, ROS Wiki is your friend. ROS Wiki, trust me, it looks a little bit simple or budgety. It's like there's not a lot of effort put into design and everything, but every info inside here is perfect. The explanation are super details. Okay, and if you really want to watch a YouTube, I would say maybe you can go for another YouTube channel, which is Robot Edu. Maybe I forgot already. Robot at Home Edu, if I'm not mistaken. Robot at Home Edu. Yeah, Robocop at Home Edu. Sorry for shouting. So, Robocop, for your information, Robocop is sort of like a Robocon. If you guys know what Robocon competition is, Robocop is another kind of competition that is very similar to that, but they are mostly focusing on ROS robot. So during the pandemic, they actually have a few series of sharing online, free sharing online, and they have made it, upload it onto their YouTube channel, and they made it into a list. So maybe I can sort of recommend you to watch a few videos of them. Don't really need to watch the entire series or the entire playlist, but you can always come here and they have a very insight or very detailed explanation on ROS and even some hands-on or even better explanation than mine. This doctor, his name is Dr. Jeffrey, who uh, who is our basically he is our sort of like a Shifu. Shifu is like it's like our teacher lah for ROS. So yeah, this playlist, yeah, later I will send inside the WhatsApp group, and you can go through starting from the 5th video. Yeah, from the 5th video, if you were to want to understand or repeat the same thing that we explained today, or even in the even more details, you can go through this video if you want. Okay, they have a lot of speech interaction, navigation, and all sorts of things that is explained over here. His explanation is tip top for this Dr. Jeffrey Tan. Shout out to him. So, okay, we have more questions. Hi, got any much difference between ROS 1 and ROS 2, especially for command? Well, if you go for ROS 2, there are a few differences in the command. And but as I said, in this tutorial, in this training, we're not going to go in detail on ROS 2. But if you want to know more about ROS 2, feel free to go ahead again, ROS Wiki. On your top right corner, there's always a recommendation for ROS 2 documentation. You can go check it out yourself. And the documentation are still tip-top as always for ROS Wiki. Okay, the documentation is perfect. You can read through everything, installing tutorials and all that are all here. Okay, there are a few differences in the command, not gonna lie. Yeah, but if you want to go through, feel free to go through as well. But as I mentioned, I want to emphasize again, ROS Wiki is your friend. ROS Wiki is your friend. Everything about ROS is over here. Okay, everything that is discussed in whether it is the robot cup at Home Edu or even the construct, they are all here. Okay, the basic stuff lah, of course. So yeah, I hope I answered all your questions. Is there any other question yet for me? If no, we can keep it for tomorrow as well. Questions? Did I miss anything? Is there any? Yeah, just now I already go through all these questions, I think. Did I miss any questions? Subscribe. No, right? I didn't miss anything, right? For Liang Ming and Liu, did I answer your questions? Okay, sure. All right. How about the rest? If you don't have any questions, don't worry. Because now we already over time like 20 minutes, so it's okay. I think we should end the session for today. Feel free to join back in or tune back in tomorrow at the same time. Yeah. If you guys want to extend also can if you guys want, or you can contact me personally if you have more questions that you want to ask, and shy to ask during the session. Okay.